Okay, so this is just looking at first order differential equations, solving them using a separation of variables method. It's a little bit more complicated than direct integration, but it's a really good one to know. Okay, so if we have a question here, the form dy by dx equals minus x over 3y, where y is greater than 0, and we need to find the general solution. This is of the form dy by dx is a function of x times or divided by a function of y. In this case, the function of x is going to be the minus x, and the function of y is going to be the third y. So that's the first thing you need to do, is identify what the function of x is and what the function of y is. There. And then what you're going to have to do is try and get all the y terms on this side of the equation, on the left side, and the x terms on the right side. So to do that, if we just multiply both sides by 3y, and so we'll get 3y on here, and then if we multiply by dx, the dx will go onto this side, and we essentially get this 3y dy equals minus x dx. Then you integrate both sides of this. What this is basically doing, you've got the dy on this side, so you're integrating with respect to y. On this side you've got the dx, so you're integrating with respect to x. And if we go and do that integration, this is what we'll end up with. Nearly done now actually. All you have to do is rearrange to make y the subject, and if we do that, we'll end up with this. Now here, as there is a b instead of a c. That's because in the rearranging process we've multiplied everything by 2 to get rid of these divisions by 2 here. So that c was multiplied by 2 as well. It is still just an arbitrary constant, but it's a slightly different arbitrary constant. I mean, you could write this as 2c if you wanted. You could just leave it as c, but I prefer to be a bit more concise and use a different sign just to show that this arbitrary constant here is not the same as this arbitrary constant here, because it's not, it's double that. This expression here is basically because y has to be greater than 0, so x has to be between minus root b and root b. If x was less than, we would get, or less than or equal to minus root b, this would be negative or 0. Similarly, if it was greater than root b, this would be negative, or if it was the same as, it would be a 0 again. So that's just solidifies this equation for what values that it can be true for. So that's the general solution there. If we have one with initial conditions, so in this one the initial condition is when y of 0 equals 5. We go about this the exact same way. G of x, the function of x in this example is minus x again. The function of y is 1 over y. So we times by y times by dx. So we'll get y dy equals minus x dx. Like so, and then we want to integrate both of those, which will give us this. The arbitrary constant, obviously you get one from both integration, but you can just sort of ignore the one coming from here, and you only have it on the left hand side. You sort of combine them, but you know, for the purposes of answering the question, you can just write it on this side and just denote it as c like normal. From here we want to rearrange to make y the subject, which is this. Again, we've multiplied by 2, so the c, I've changed that to a b. And now that's the general solution. We just need to find the solution that satisfies this initial condition. So to do that, we take the value in the brackets here, substitute every instance of x in the general solution for that value. So that would mean we got y of 0 equals b minus 0 squared, because the x changed to a 0, and that has to equal 5. Now obviously 0 squared is 0, the square root of that is also 0, so what we've got is root b has to equal 5 to satisfy this initial condition here. So if the square root of b is 5, b must be 25. So we now substitute what we found as the value for b back into the general solution, like that, and that is the solution that satisfies the particular initial conditions specified in the question. So that's it, that's all done. I mean, these aren't difficult examples. It's not too hard to do once you've got your head around it. They're not tough examples, but it's the correct method, and if you just use the right method, as long as you don't trip up on anything silly, then this will work all the time. It's a good one.